Hello everybody. This video presents a tutorial to use ProsoBox, a Praat plugin for prosodic analysis. ProsoBox is in fact a collection of Praat scripts whose main functions are as follows. Segment a sound file into interpose units or units separated by pauses. Automatically detect prominent syllables. Extracts a series of prosodic measurements at various levels like syllables or units separated by pauses, or even a complete sound file. And export these prosodic measurements as tables that can be used for statistical analysis or as graphical representation that can be a static image or an interactive panel. To download and install this plugin, go to gitlab.com/pratplugins. The reference article is published in the Proceedings of Speech Prosody 2020. To use ProsoBox, you need two input files, a sound file and a segmentation file called TextGrid that contain a segmentation into phones and syllables. You can also have a segmentation in words. This segmentation can be easily obtained using the Easy Align plugin. You process one sound file and one corresponding text grid, or a collection of sound file and the corresponding text grid, as long as each sound file corresponds to a text grid with the same name. We will now explore the different scripts included in ProsoBox. All the information given in this video can be found in a written tutorial within ProsoBox itself, in the Help section, so you can read it directly under Praat. Your text grid file and your sound file must be in the same directory. The first step of the ProsoBox is the Prosogram script in its version 2.4. It's a script developed by Pete Mertens. This script provides a stylization of the fundamental frequency for the file, as well as a table that gives a prosodic measurement for each syllable. In the form, under Input Files, specify the path to your sound file. If you process one sound file, you specify its name. If you want to process a collection of files, you can write a star character so that the script will process all the files in the directory. For the segmentation method, make sure to choose syllable nuclei around the vowel in the phonetic tier. It is not necessary to generate a graphical representation. What we are interested in here is the table of syllables. This script will create a syllable table with prosodic measurements for each syllable. The goal of the second step of the ProsoBox is to create a tier with speech segments, that is to say, units separated by breaks or pause. The user indicates the pause threshold he wants to use. It means the minimal duration of the pause. By default, this threshold is set to 250 milliseconds. Please enter the name of the existing syllable tier and the name of this new tier that you want to create with the units separated by pauses. Once the script is applied, it modifies the original text grid to add a new tier with units separated by silent pauses. In step 3, we want to automatically detect prominent syllables using the Prosogram script. This script uses parameters that can be changed in two submenus, which will not present here, but they are described in the help menu. Prosogram takes as input the sound file and the corresponding text grid. It will detect prominent syllables from the fundamental frequency and the relative duration parameters. Each syllable will be compared to the surrounding syllables in its local context. This local context is defined in the scope section of the form. By default, the local context includes the two preceding syllables and one following syllable. So each syllable will be analyzed in a context of 4 syllables, including itself. And of course, the range of this context can be modified by the user, as well as the weight applied to each syllable. The default strategy is the so-called threshold strategy. In other words, a syllable will be considered as prominent as soon as its relative height or its relative duration or the melodic movement exceeds a specific threshold defined in the submenu called thresholds. The default values come from a previous study. Every syllable annotated as prominent receives the label P in a new tier of the text grid called Promoto for automatic detection of prominent syllables. An evaluation of the automatic detection can be carried out to compare with the former manual annotation. When the script is launched, it modifies the text grid and adds a series of additional tiers. The tier Promoto contains now, for each syllable, the detection of the syllable as prominent or non-prominent, a label P or an empty interval. For each syllable in the text grid, 3 additional tiers have been added: relative F0, relative duration, and melodic movement. The tier
Pour chaque
shows the
syllabe
values
du
for
text
each
grid,
syllable in its local context. This syllable within the word station has been detected as prominent because the 3 threshold has been reached, which is indicated by the hash sign before the values. This syllable has a relative height of plus 6 semitones, which means it is 6 semitones higher than the average of the 3 surrounding syllables. This syllable has also a relative duration of 2.16, which means it is 2.16 times longer than the surrounding syllables. And it has an intrasyllabic melodic movement of plus 4.09 semitones. Some syllables are detected as prominent because they reach the 3 thresholds. Most of the time, syllables are detected as prominent with a unique threshold because of its relative duration or its relative pitch, or sometimes only because of the melodic movement. The set of relative prosodic measurements that have been added to the text grid can also be viewed in a table. This syllable table, also called the seal sheet, is modified by the Prosogram script and can be read as a table in a spreadsheet software like Excel or a statistical software like R. For example, here we can see for each syllable in the file, the relative fundamental frequency, the relative duration, and when there's a positive or negative melodic movement, the value of this movement. At the end of the presentation, we will see how to graphically represent the prominent syllables. Here we can see a red line for each prominent syllable, a red value for relative fundamental frequency, a green value for relative duration, and a blue value for the melodic movement. These values of prominence detection can be visualized in the text grid, in a spreadsheet, and also in a graphical representation. The next script in ProsoBox allows you to create a table for speech segments or interposal units. The idea is to create a table from which prosodic measurements are extracted, such as articulation rate, speech rate, melodic range, and the proportion of prominent syllables for interposal units. That can we call prominence density. It is also possible to compare prosodic parameters from one interposal unit to the next one. For example, to detect variation in speech rate, like rhythm accelerations or slowdowns. The script called MakeSSTable will create a new table that you can also read in a spreadsheet. For each interposal unit, a series of measures are provided, such as its duration, articulation time, articulation ratio, the average syllable length, the lower and the upper pitch value expressed in semitones. We apply here a script called Prosody. Prosody generates a dynamic display panel of the evolution of speech rate or of the pitch range or the melodic variations or even the prominence density for a whole file. The analysis is done on the basis of a sliding window. You can modify the width of this window. Depending on your study, you may want smoother or sharper curves. The lower pane represents the interposal units. Here we see the evolution of the speech rate, which varies from 2.9 syllables per second to 9 syllables per second. We are going to listen a very quick passage and a very slow passage.
Et 10 civils palestiniens ont également été blessés. À l'intérieur du bâtiment, mais une trentaine.
So we listen to two samples of speech with a high speech rate and a low speech rate. We can now display the variation of the average fundamental frequency in semitones. We can see the samples with a higher pitch range and the ones with a lower pitch range. The next script is called Replot Enriched Prosogram. It is a variation of the Prosogram script by Pete Mertens. These scripts make it possible to generate an enriched prosogram with measurements on syllables and measurements on interposal units. The lower part of the form allows you to select the units to display: speech rate, fundamental frequency, for example average, range, minimum and maximal value, etc. And also the units for this F0, semitones or hertz, and also how to display the prominence density. The script will generate an enriched prosogram where the prominent syllables appear in red and the interposal units are separated by the vertical black lines. When you open this file, you will find the different measurements, the measurements per syllable detailed by the Prosogram script, and the measurements per interposal unit, the number of syllables, the fundamental frequency, the speech rate, and the prominence density. The last script of the ProsoBox is called ProsoReport. This script allows you to generate a global prosodic report, which will give several dozens of prosodic measurements for an entire speech recording. This script will generate another table based on the syllable table. The plus for this script is that it can be applied to a series of files, 5, 10 or more, and you get two columns with the average and the standard deviation values for the whole series. Hence, you can compare easily two groups of files. We have, for example, the recording time, the speaking time. There is also pitch range values, the number of static, rising and falling tones, the percentage of prominent syllables and non-prominent syllables. It is a complete and general prosodic report on a speech file. As a conclusion, all this information and much more is available in the ProsoBox manual directly within Praat. ProsoBox can be downloaded from the GitLab platform. We hope that you enjoy this script and thank you for watching.